Hi everyone, this is the review for exam 2. So this exam is posted on Blackboard. It should already be posted with a blank version and a filled version that will match what I do in this video. So this is a really good representation of what the exam will look like with point values along the side of the exam to kind of indicate to you how much each type of question will be worth. You can see right now there's 12 questions and the exam's out of 120 points. So the actual exam will be 10 questions with 100 points. So it'll be really similar to this, and I'll explain more about the differences at the end of the video. But for right now, we're just gonna go through it. So one thing that you'll definitely need to know for the exam are the divisibility rules. So go back and review these from chapter 5 if you don't remember them. But the divisibility rule for 2 is that the number is even, is one way to say it. But another way to say it is that the number ends in 0, 2, 4, 6, or 8. Those are both ways to say the divisibility rule for 2. The divisibility rule for 3 is that the sum of the digits is divisible by 3. The divisibility rule for 4 is that the last 2 digits of the number are divisible by 4. The divisibility rule for 5 is that the number ends in 0 or 5. The divisibility rule for 6 is that the number needs to be divisible by 2 and 3. The divisibility rule for 8 is that the last 3 digits are divisible by 8. The divisibility rule for 9 is that the sum of the digits is divisible by 9. And lastly, the divisibility rule for 10 is that the number ends in 0. So these are all just the basic divisibility rules. So all of these are for base 10. So these should match what's in the book, what's in the notes, and all of those things, just to make sure that you know all of these divisibility rules, and it helps to know why they're all true as well. Okay, so next we talked about primes and composites and factors of a number, prime factors of a number. So we want to list all the factors of 80. So people can kind of do this in different ways. So the way that I'm going to list them out right now is we always know that 1 is a factor of every number. But if we use our divisibility rules, we see that 80 ends in a 0, so it's divisible by 2. The sum of the digits of 80 is 8, which is not divisible by 3, so 3 is not a factor of 80. 80 is divisible by 4 because 20 times 4 is 80. 80 is divisible by 5 because it ends in a 0. 80 is not divisible by 6 because it's not divisible by 3. 80 is not divisible by 7 just because you should know your multiplication table for 7 up to 12, and 7 times 12 is 84, and 11 times 12 is 77. So it's not divisible. 80 is not divisible by 7. Okay, 80 is divisible by 8 because 8 times 10 is 80. 8 is not divisible by 9 because the sum of digits is 8, which doesn't divide 9. And we see that 80 ends in a 0, so it's divisible by 10. So I'm going to scroll past those divisibility rules now, and now I'm going to start doing pairs of numbers. So we know that 8 and 10 make 80. So we need to find a number that is 80 divided by 5 is 16. You can use the half and double rule here to see that. I'll make that a little bit narrower. 5 and 16. 80 divided by 4 is 20. So we have that 4 goes with 20. 80 divided by 2 is 40. 2 goes with 40. Then lastly, 80 divided by 1 is 80. So we have all of the matching things here. So these are all of the factors of 80 because we checked it up to 10. And at 10, we already started having this pairing occur. So now we want to write the prime factorization of 80 as a product of powers. So I think the easiest way to decompose 80 into small enough numbers is to just have 80 equals 8 times 10. And 8 has the prime factorization of 2 cubed. And 10 has the prime factorization of 2 and 5. So when we combine the 2 cubed and the 2, we just get 2 to the 4th. So 80 is 2 to the 4th times 5. So that's the prime factorization of 80. So now we want to find the LCM and the GCF between 80 and 12. And we want to look at the prime factorization of both numbers to do this. So in number 3 above, we've already found the prime factorization of 80. So now we just need to recall that the prime factorization of 12 is 2 squared times 3, because 12 is 4 times 3. And to do this one, I want to use the Venn diagram because I like it. So we have this Venn diagram. So we have factors of 80 on one side and 12 on the other side. So what do they have in common? Well, they both have 2 2s, and then 12 has a 3, and then 80 has 2 more 2s and a 5. So remember that whatever's in the intersection is the GCF of 80 and 12 is 2 squared, which is 4. And the LCM, we just take all of the numbers. So this is 2 to the 5th times 5 times 3. And you don't have to expand this out, but this is 32. Oh, I'm sorry. That should be 2 to the 4th. We only have 4 4s in there. So this is 16 times 15, which is 30 times 8, which is 240. So you don't have to expand this out. If it tells you to use the prime factorization of both numbers, you can just keep it as these products of primes. And that's a perfectly sufficient answer, especially if it tells you to use prime factorization. So you can keep it like that. You don't have to multiply it out, especially if you want to cut down on your arithmetic errors during the exam. One thing also to note is that you need to write clearly which number is the GCF, which one's the LCM. So you need to clearly label that on the exam, or else I'm not going to know which is which, especially on a question like this that asks for 2 different values. You need to clearly label them. Okay. So all of these 3 questions are kind of related in one. They all kind of relate to each other by using this number 80. Okay, next we get into the material from chapter 6. Oh, yeah, chapter 6, which is about fractions. So we want to draw the area model to represent 2 3/4. So because the denominator here is 4, we know that every whole we have is going to be divided into fourths. So 2 3/4, well, we're going to have 2 wholes. And then we're going to have another whole that's going to be our fractional part. So we're going to have 2 wholes that are in fourths, and then this one that's in fourths. So we want to shade in 2 3/4. So we're going to shade in 2 of these completely because we have 2 wholes. And these 2 wholes are the whole number part of this mixed number. And then we're going to shade in the fractional part where we shade in 3 out of 4 of that last whole. So this is just 3 out of 4. And that's the area model. Okay, number 6, we want to use fractions to write these numbers from least to greatest, and we want to use a number line and or benchmarks. So I'm going to draw a number line first. And I'm going to have, these are all fractions, so they're all less than 1. So I'm going to have 0 here, 1 here, and then 1/2 in the middle. Okay, so what do we do first? So we have 1/2 there. So 1/2 has already been accounted for. Okay, so 1/2 is there. So next I'm going to look at the 1/12 and the 1/4. So I'm going to look at 1/12 and 1/4. Well, I'm going to compare each of these to 1/2 rather. So 1/12 compared to 1/2. So we know that 12 is greater than 2, but whenever we let me start over. So we know that 12 is greater than 2. So if we take a whole and we divide it into 12 parts, those parts will be smaller than if we have a whole and just divide it into 2 parts. So we're comparing a whole with 12 parts and a whole with 2 parts. So the whole with 12 parts, each of those pieces, so 1/12 of that piece is smaller than 1/2. Similarly, we have that 1/4 is less than 1/2, because if we take a whole and we divide it into fourths, each of those pieces is going to be smaller than if we have a whole and just break it into halves. So both of these are smaller than 1/2, but how much smaller are they? Which one's bigger than the other? So we can compare 1/12 and 1/4 by using a common denominator. Well, you don't even have to use a common denominator. You can think about this in the same way as if we take a whole and we divide it into 12 pieces. Each of those pieces is going to be smaller than a whole divided into 4 pieces. So we know that 1/4 is somewhere less than 1/2, and then 1/12 is somewhere less than that. Okay, so now we have 1/12 and 1/4 placed. So now we need to look at 3/4 and 7/8. So first, let's compare those and see which side of the number line they're on. Are they bigger or less than 1/2? Well, 1/2 is 2/4, which is less than 3/4. And similarly, 1/2 is 4/8, which is less than 7/8. So both of these are greater than 1/2, but let's see how they compare to each other. So these two we can compare. Oh, my apologies. 3/4 is less than 4/4, which is 1. 7/8 is less than 8/8, which is 1. So both of these are between 1/2 and 1. So now we want to compare 3/4 and 7/8 to see which one of them is bigger. So 3/4 is 6/8, which is less than 7/8. So we know that 3/4 is going to be somewhere like that, and 7/8 is going to be bigger than it. So now we've placed both of these. So now all we need to do is write this in our final form. So we want to write them from least to greatest. So the least is 1/12, then 1/4, then 1/2, then 3/4, and then 7/8. So this is our final answer in order from least to greatest. And remember that your work is just as important as your answer. So although I do appreciate when you box your answers so I don't have to find it in the middle of your work is just as important, if not more important. Okay. Next, we want to use pattern blocks to explain how to add fractions. So we want to add 1/3 and 1/6, and we can use a hexagon, an equilateral triangle, a parallelogram, or rhombus, whatever you want to call it, and a trapezoid. So first off, whenever we're dealing with pattern blocks, the first thing that we need to do is to determine what will be our whole. So these are pretty simple fractions, 1/3 and 1/6. And I know that a hexagon, right, it has 6 sides. So I can easily split a hexagon into a third and a sixth using the equilateral triangle and the rhombus. So I'm going to say that the hexagon is my whole. And then when I divide that hexagon into 2 pieces, right, if we do something like that, I get a trapezoid as a half. If I divide it into 3 pieces, like so, I get the rhombus as a third. And if I divide it into 6 pieces, I get 6 triangles. So if I divide it into 6 pieces, like so, I get the triangles. Oh man, sorry, that should be 1. This should be 1/6. I don't know why I kept writing a half here. Okay, so we have one whole, and then each of these shapes represent those corresponding shapes. So we just want to explain this. So if the hexagon is our whole, then the rhombus represents 1/6, and the triangle represents 1/3. Okay, so that's all we've done so far, is to say what different things represent. So now if we want to add these on our hexagon, so remember, if we have our rhombus on our hexagon, it looks like so. Well, I'll probably do this in blue just so it's a little bit clearer. So if we have a rhombus in our hexagon, right, it looks like so. And we want to add an equilateral triangle. So we want to add a little triangle piece down here. So if we put these on our hexagon, we can see that we've shaded exactly 1/2 of the hexagon because we have a trapezoid left over, because this part that's remaining is the same as a trapezoid, right? Sorry, that purple's a bit hard to see. I'll redo it in green. So what we have left is this green trapezoid. Okay, so if we put these pieces together, we see that we fill up half the hexagon. So 1/6 and 1/3 is 1/2, because we had the trapezoid shape made from the rhombus and the triangle. So make sure that you can explain in words and pictures and whatever else you need to how to use pattern blocks to add different numbers. And if I had more room, I know I said it audibly, but you should always say, what is your whole? Right. Oh, I did write it down there. If the hexagon is our whole, so that's the first step, is always to say what your whole, then to say with the other pieces, what shapes represent their fractions that you care about. Yeah, and so on. So a lot of times we use those two hexagons together to represent our whole, and a lot of times that was because then a trapezoid could represent a fourth. But in this problem, we didn't need a shape to represent a fourth, we just needed a third and a sixth, which worked nicely if our hexagon was our whole. But you should be able to do it with any simple fractions like that in these shapes to say what's your whole, what shapes represent the fractions that you care about, and then how to add them together. Okay, number 8 is a lot of fraction operations. So whenever you're doing this, you shouldn't ever on any of the problems ever just put the answer. You need to show your work. So when you add fractions with unlike denominators, the first thing you need to do is get a common denominator. So 3/4 plus 1/12 is the same thing as 9/12 plus 1/12, and then we just add straight across and simplify if possible. And it wouldn't hurt to go ahead and put each step on a different line and to put what you're doing. So this is you're finding and rewriting with a common denominator. In this step, you're actually adding addition. And then in this step, you're simplifying. And so you get 5/6. Okay, the next one, we have 3 1/3 minus 3/4. So we write this, again, using a common denominator as our first step. So 1/3 is 4/12. 3/4 is 9/12. So again, our first step is finding a common denominator. Okay, so the next step, we are trying to take 9/12 away from 3 and 4/12. So you could either rewrite it as a mixed number, might as well. We'll rewrite it as a mixed number. So 3 represents 36/12. So this is 40/12 minus 9/12. So this is rewrite as an improper fraction. Then we actually subtract. So 40 minus 9 is 31. So this is the subtracting part. So depending on what the instructions say, you don't have to convert your answer to a mixed number. So the instructions on this problem don't say what form to leave your answer in. So you can leave it as this improper fraction, but if you don't want to, this is 2 and 7/12. This is the simplifying step, where this is just 2 and 7/12. Okay, next, multiplication. So the first step is to just multiply. So this is 32 times 30 over 15 times 8. So this is just going straight into using the multiplication algorithm. So then we know that 32 can be rewritten as 4 times 8, and 30 can be rewritten as 2 times 15. So we can cancel a 15 on top and bottom and 8 on top and bottom. So this is just 4 times 2 over 1, which is 8. And so all of this was the simplifying step. So this is just 8. Okay, dividing fractions. We do the flip and switch. So this equals 42 over 60 times 72 over 21. So this is doing the flip and switch, however you want to call it. I've started using this just because it's the fastest thing. So we know we multiply straight across. So this is the multiplication step. And then we know that we can write 42 as 2 times 21. And we know that we can write 72 as 6 times 12. We can write 60 as 5 times 12, then 21. So the 21s will cancel and the 12s will cancel. So this is 2 times 6 over 5, which is 12 over 5, which if you want to write it as a mixed number, this is 2 and 2/5. So all of this again was the simplifying step. Okay. So on the exam, I'm sure I'll write directions that tell you to simplify it in what way. To either reduce it to the lowest terms will likely be what's written there. I don't anticipate that I'll tell you to write it as a mixed number, but you should know how to write improper fractions as mixed numbers and vice versa. So just know how to do all 4 operations with fractions. And in particular, be able to explain how to do all the operations with fractions, right? These questions are how to add, multiply, divide, not subtract, but rewrite an improper fraction as proper fraction. This should say divide. So be able to explain how to do all of these things. So let's go ahead and write these steps. So how do you add 2 fractions? So the first thing we do is get a common denominator. The second thing is to add the numerators. The third thing is to keep denominator the same. The fourth thing is simplify, right? The last step is always to simplify if possible. Okay, and I'm just rewriting these steps from what we've done in the notes. So you know how to do these steps and you've seen it in the videos, so I'm just rewriting what they are here. How do you multiply 2 fractions? Well, we multiply straight across. So we multiply the numerators. We also multiply the denominators. And then we just simplify. Okay. How do we divide 2 fractions? Well, we can either do it with a common denominator or not, but I'm going to do the general case. So we rewrite the problem as multiplication by the reciprocal of the divisor. So we do the dividend. Instead of the dividend divided by the divisor, we do the dividend times the reciprocal of the divisor. We rewrite divisor here. Number 2, we multiply using the multiplication algorithm. And then we simplify if possible. Okay. Lastly, how to rewrite an improper fraction as a proper fraction. So more precisely, how to rewrite an improper fraction as a mixed number. So we divide the numerator divided by the denominator, and our quotient becomes the whole number part and our remainder over the denominator becomes the fraction part. So this is rewriting an improper fraction as a mixed number more precisely. So at the beginning of the video, I noted how there were 12 questions and the exam was out of 120 points. That's because I went ahead and included all of these on the review. How to add, subtract, multiply, divide, and rewrite fractions. So you won't be tested on the exam. There won't be all 4 of these, nor all 5 of them if you added in subtraction. There will just be a few of them. So I just wanted to have them all on the review so I could just go over them with you again. And the one that wasn't on the review is how to subtract 2 fractions, but the only difference between subtracting 2 fractions is that this add here just changes to subtract if you're subtracting 2 fractions. So I didn't feel like it needed its own question here. Okay, so this is the review. I hope that this has been helpful and it will help you studying for the exam. Feel free to email me if you have any questions. I'm here to help you, and best of luck.